So this last video is going to cover kind of the last bit of volumes of revolution, which is to say that everything that we've done so far has involved rotating some region around either the x or the y-axis, which is fine and dandy, but there are other lines that we could rotate these 2D areas around. And so the focus of this video is going to be, what if we're going to take a region and rotate it around the line y is equal to -4 or x is equal to 2 or stuff like that. And so that's where we're going to start. We're going to do a couple examples to kind of, answer the question, what happens if we're asked a question like that? So for this particular example, we're going to take, let's say, the graph of y is equal to e to the x. And let's say that it's trapped by the lines, let's say it's trapped by x is equal to 1 and x is equal to 4. Okay, so let's say we have that trap. So we're talking about, and it's also trapped by the x-axis. So we're talking about rotating this particular region around something. But now we're going to, instead of rotate it around the x-axis, we're going to rotate it around, well, I said it earlier, y equals -4. Let's do that. Let's rotate around the line y is equal to -4. So maybe not drawn to scale, but that's not drawn to scale just so I have enough space to illustrate what's going on. So y is equal to -4. Okay, first and foremost, don't forget how to draw a straight line like y equals -4. A lot of times people draw it erroneously straight up and down over there. Y equals -4 is that line there. And now, we've learned a couple different methods for doing this sort of problem, but for this particular one, I'm going to take our shaded region up here, and we're going to take some straight up and down slices. I could take horizontal slices, but I'll do that in the next example that we do. So we're going to take this region. I'm going to take a straight up and down slice. So let's see, what color should I use? Let's use blue. Okay, and we're going to take a slice just like so, and I'll make this rectangle perhaps a little bigger than normal. And now the very interesting question is, how do I deal with the fact that I'm rotating around not just the x-axis? Because if I was just doing around the x-axis, right, we would just get a disk just like so, and that would be pretty easy. But now, right, we have a washer, and we have a washer that follows kind of a very interesting path. Okay, so let's get this kind of sketch going. All right, so there's our washer. And as I keep kind of stressing in these problems, you need to be able to draw these sketches to really have a good idea of what the heck's going on. And so in this particular case, right, in the way that I've drawn this, we're still going to use the same exact formulas as we've been doing before. So, right, we're adding up total area, total volumes, which is surface area times the thickness, and so we're going to have like an outer surface area and an inner, and because we're doing the disks, we can use the formula pi. We have our outer radius squared minus our inner radius squared, and then because I took my strip to be straight up and down, we'll have dx. So again, the only real trouble here is figuring out what this outer radius is. Okay. So the nice thing is, though, is that, we know how to do distance. And so if we look at this drawing, we can say, okay, well, I know that if I'm at this point on my red graph, y equals e to the x, then the distance from that point down to the x-axis, that's just my y value, whatever that is. And then I have another, right? I have another distance here to basically the center of my axis of rotation, and that distance right there is just equal to 4. So my outer radius here looks like it's going to be my red y value plus another 4, right? And that's how I'm going to leave it for now, right? It is the y value that I'm getting from this equation here. And then we're going to subtract whatever it is that we get doing the other one. And so we'll look at the inner radius now. There should be an I there. The inner radius. And the same thing. Well, in this case, my bottom function is just the very simple x-axis. It's the line y equals 0. So not much to do there other than identify that, well, my that my inner radius is just going to be that distance of 4 right there. So I'll have 4 quantity squared. And this is how you can address a problem like this. So if we have, if we put this all together, the last thing would be to put some bounds in here, and I gave them to us, x equals 1, x equals 4, right, and squared, and then we're good to go. So we'll have pi times the integral from 1 to 4 of, now, y plus 4, but we're integrating with respect to x, and that y value comes from this particular function, so we're going to replace it with e to the x plus 4 quantity squared minus 16 dx, and this expression is going to do it for us in terms of getting the volume of whatever this shape ends up being when we rotate it around. And it's going to be some really big sort of shape. Oops, maybe not that big here, right? Something kind of like this. And it's going to kind of do this, and it's going to be kind of hollow in the middle, right? And so on and so forth. So whatever this particular 3D region is that we would get, this is the formula that we would use for it. So now let's revisit, that was, an example using the disk method or the washer method in this particular case. But now let's do one that does the cylinder shell method. So let's see here. So let's make our graph x and y. And for this example, let's just make the simple parabola, right? This is going to be the simple parabola, x is equal to y squared. We're going to trap it by, let's see here. Can we do anything interesting? Let's trap it by a line kind of going like this. Okay, and let's make this line y is equal to x. Let's see here. Y is equal to x minus, 5? Yeah, let's do minus 5. Minus 5. Okay. So there we go. So we're talking about getting this region right here. And we're going to rotate it now around the same axis. Let's aim for the same axis. So y is equal to -4. So let's get the dashed line out. Okay. So the same exact axis, y is equal to -4. Y is equal to -4. Right. And we notice that in this particular example, right, our vertical strips won't really work. They kind of work over here, but they don't work over here because I'm hitting the same graph. And so in this particular example, we're going to need to take horizontal strips, right? Nothing too intimidating. We've covered this kind of extensively in the last videos that we've been working with. So let's see if it'll let me draw a rectangle. Nope, come on. Let's draw a rectangle up here and then move it. All right, perfect. So let's take that. Let's draw our little rectangle, something like so. Okay. Right, so we're going to take a horizontal strip at some particular y value. Now, one of the first things we would have to do again is to figure out this intersection point, right? What is this top y value? And we'd have to figure out this bottom intersection point to get this bottom y value. But for now, I'm just going to preemptively set up my integral to go from y1 to y2. And because I already know I'm taking horizontal strips, my thickness is going to be dy. And then we just need to remember our formula, which is, again, if I take this shape and we rotate it around this axis, and I will keep stressing it the entirety of this video, you need to make semi-accurate sketches. That way, when you're trying to figure these questions out and trying to answer like the different little pieces, you don't get confused in what the heck it is you're doing. So we're getting a cylinder here, and that formula is 2 pi RH, because that is the surface area of the wall of one of these cylinders here. All right. And so we only have two questions to answer, which is what is the radius in terms of y and what is the height in terms of y. So let's tackle the radius. All right. So let's see here. So the radius is going to be the distance from, maybe I'll use a highlighter instead. The radius is going to be the distance from the outside edge all the way to the center of our rotation. And we need to pay close attention to a couple things, which is that we already know that the distance from the x-axis down here, right, this particular distance in this chunk is going to be equal to 4. So this is a distance of 4. And then similar to the last video, right, this total distance right here from wherever it is that we made our slice, that's just y, right? That is a distance of y. So in this particular case, wherever it is that we made this slice. The radius is going to just be whatever y value that we happen to be making the slice at, and then plus another 4. So that's going to be our radius. Fantastic. Now, let's erase that, make some space, and now let's talk about the height. So the height, again, is not anything that's too bad, right? The height is just going to be the length of this red rectangle, which, again, is going to be, right, if there's a point on this green graph, it's going to be whatever this x value is that corresponds to the green graph minus whatever this particular x value is that corresponds to the blue graph. So for the height right now, I'll kind of just throw in that this is going to be the x value for the green graph minus whatever x value we would have for the blue graph, like so. And again, those x values are different. They come from different graphs. And we need to get both of them in terms of y because we are integrating with respect to y. And so we'll take this first one and very quickly solve it to get x. And we'll get that x is equal to y plus 5. So that's not too bad. And then in the other one, we already are given that x is equal to y squared. So we just have a minus y squared here. And we're pretty much done. So barring, actually taking these and setting them equal to each other and finding exactly what these bounds are, we have our integral ready to go. It's going to be 2 pi times the integral from our first y value to our second y value of y plus 4. That was our radius. And then we have this other one, which is y plus 5 minus y squared dy. And then to solve this, we would have to FOIL everything together, right? We'd have to multiply that y there, and that y there, and that y there, and then we'd have to do the same thing for the number 4, right? We'd have to FOIL everything together, expand it out to get a really long polynomial, and then we just do all of the individual little integrals, which these are all polynomials. They're all just going to use the power rule and be relatively straightforward for us to do. And so, yeah, I mean, that's it. We're just going to stop the video there. Really, all we need is 2 examples. It doesn't matter, if I had given you an example like this and said rotate, around, let's say, the axis x equals -2 or something like that, right? Then our drawing would just pivot, right? And we would end up getting, we'd go back to the disk method, right? We'd have disks. And we'd have to ask ourselves, okay, what's our inner radius, what's our outer radius, etc. Nothing changes. So the 2 cases that I've done cover every single variation that you will end up seeing on the homework. And you just have to approach them in a slightly different manner depending on which one you're doing. But the most important thing is you need to take your time and make semi-accurate sketches. They don't have to be the most perfect sketches in the world, but they should be accurate enough that you can see what you're doing. Using different colored pens is a really good way to help you make sure that you're not going to make any mistakes in these sketches. So I would highly recommend, if you have some pens or colored pencils or crayons or something, right, to just use different colors while you're doing this your assignments. That way it's easy to differentiate what your outer radius is, what your inner radius is, what your height is, things like that. Okay, so that's going to do it for Volumes of Revolution. That was 3 videos to cover one single topic, but hopefully I broke it down into nice bite-sized pieces, and it's not too bad. So when you're done with this stuff, we're going to just kind of pivot on to really next week's material, and next week's material starts to cover our first foray into a variation of solving integrals. So if that video is up and you're ready to head on, then go ahead and check it out.